Hello world, welcome to my nerdy journal. The project of this video is speaker classification. To be more specific, I want to detect whenever Mark Rutte is talking or Hugo de Jong is talking. The first step is to collect a lot of audio data, preferably labeled data. The second step will be to normalize and clean the data. The third step is to create a model which can solve the problem. And after that, we will need to train the model on a powerful computer. The last step is to explore the model and see how well it performs in the field. This is the most fun part. First, I decided to download the past samples. These are data samples of people who we want to detect. As the title of this video suggests, we are going to download data samples of Rutte and Hugo. This is easy since the Dutch government uploads all corona press conferences on YouTube. When the press conferences have been downloaded, I separated the different speakers with an editing program and stored them separately. After this, we will need to download the negative samples. Negative samples are in this case other people talking. I download Mozilla Common Voice for the negative samples. I also downloaded some noise from Kaggle and YouTube. For the noise samples, I selected weather sounds, running tap water and pink noise. For convenience, we convert all audio files to uncompressed audio files with a bitrate of 16 kilobits per second. This poorly designed bash script will convert all audio files in a desired format. The model itself isn't original and is based on the model Fadi Badine developed. To create the model itself, we also need to apply some model-specific transformations to the data. For example, I decided that the model will predict the speaker on samples of 1 second each. This makes it possible to easily classify multiple speakers in large audio files. On each of these audio files, I will also apply noise. This helps the model to generalize more. After adding noise, I transformed the audio to an easier representation. This is done with the Fourier transform. I could also remove certain bands from the transformed data to generate more samples and make the algorithm detect speaker with fewer data points. I have not implemented this last thing. By the way, don't try to copy the code I'm writing on the screen since it's incorrect and contains many typos. Now you can see the training process of the machine learning algorithm. I don't expect much good from this since I were lazy and only extracted 200 megabytes of each speaker, while I have 3 gigabytes in total. The model itself is not much different from any other classification model, except that it uses 1D convolutional layers instead of 2 or more dimensional. The training itself went rather quickly, but I'm a bit biased since I sold a kidney for this computer. Now we are at the great moment everyone waited for. For this, I will create a Python script that can create labels for Audacity. For the people more experienced in this field, the sample I'm going to display in a minute has never been seen by the algorithm and is completely new.
Goedenavond. Zondag jongsleden sprak de voorzitter van het Veiligheidsberaad, burgemeester Hubert Bruls van Nijmegen. April, zoals eerder besloten. We zijn natuurlijk blij dat dit nu kan, want de samenleving snakt naar meer ruimte. Nodig zijn om ervaring op te doen, om te kijken wat kan wel en niet.
Ja, het ging hier vandaag veel over zorgpersoneel.
If you have experience with Audacity, you could see that the labels are not perfect, especially towards the end where the interview is. This is because the negative samples don't compare to the environment of the interview. What I mean by this is that we use Mozilla Common Voice for the samples of other people. The samples in Mozilla Common Voice are of really high quality. In the interview, people are talking over each other, which is completely different from the data our algorithm has seen. Thank you for watching.